Welcome back, everybody, and in today's video I'm going to go over these three relationships between sine and cos. So if you're doing any trig related course, then there is a good chance that you either need to know these or should be aware of them or be able to derive them. So what I'll do is I'll go through each one individually and I'll use radians and degrees, so then it's more versatile for all the courses that involve trig. Let's dive in. Okay, let's take a look at this first property. So in the top corner, I put radians and degrees. Please just use whichever one that you're more comfortable with. It makes no difference in the property. So we have to show really why sine negative theta is minus sine theta. Well, on this unit circle, I've just drawn a triangle with an arbitrary angle theta. Now remember, the opposite side of this, if we're using SOHCAHTOA, but this time just sine, the opposite side is sine theta times h, but sine theta times 1 is just going to be sine theta. So the height of this triangle is just sine theta. And that will be this point here, right? Now, what happens is if we put a negative angle in, then we just rotate clockwise around the unit circle. So rotating clockwise around will result in the point being here. Now, if we just join up another triangle, we basically got an identical triangle. It's just reflected in the x-axis. And therefore, then, this value on the y-axis here will be negative sine theta, because it will be exactly the same length as the first triangle, but it will just be beneath the x-axis. Hence the reason why we say x-axis reflection. Let's go ahead and look at this same sort of idea for cos. So I'll just put a triangle on for you to visualize this. So cos theta was the adjacent side. So this is this length here. This is cos theta. Now, if you rotate instead in the negative direction, you will just rotate in the clockwise fashion and we'll have exactly the same style of triangle, okay, as the previous example, okay? But we can see horizontally, if I get the laser pointer here, horizontally, this triangle is still exactly the same as the previous one, the yellow one. So therefore, the value for cos theta won't change. It will stay exactly the same. Hence the reason why cos negative theta is just equal to cos theta, because it makes no difference. The side length of that triangle is exactly the same. Okay, property number 2. So this involves a measure of turn, like a rotation, and that is pi. Don't forget, pi is 180 degrees. So just switch out the radians for degrees if you need to. So it says that these two things are exactly the same. And why is that? Well, if we go around 180 degrees, so like if we're starting off with this value, if we move 180 degrees around the unit circle, we will be all the way over to here, right? And then it says subtract an angle. So then you would move backwards like this value theta. So therefore, the value theta would be in this quadrant here. Note, it doesn't actually say that theta is between 0 and 90, but in almost every single exam case, it will say that. So therefore, then, what we've got is it wants sine. Sine is a measure of height. So the height of this value is just going to be sine theta. And that is it. So as we've moved all the way around to pi and back theta, the height of this thing here is just still equal to sine of this value, sine theta. Let's move on to cos. If we rotate around to pi, which was here again, and then move back a certain measure of theta, we will have that triangle there, okay? And that is theta then inside, because we moved to pi, then back theta. What is that equal to? Well, if we're finding cos, cos means horizontal. Now, if we're horizontally measuring this, don't forget we are now to the left of the origin. So that means that value won't just be cos theta, will be negative cos theta. There. Hence the reason why these two things are equal to one another. Okay, on to our third property. This one is a little bit more complicated than the other, but I'll still show you in the same type of manner. So we have to work with 90. Now, pi over 2 is 90. So it's 90 minus some angle then is equal to cos. So sine of that value is equal to cos. How does that work? And imagine that we are starting at 0, and then we move to 90. So that's up here. Then we subtract theta. So we're going to be moving back this way, right? So what I will do is I'll just put a little marker on here that this is where we've ended up, right? So we move to 90, then back. So that means that this angle inside here is pi over 2 minus theta, or in other words, 90 minus theta, right? So what next? Well, if that's 90 minus theta, it must mean that this angle down here is theta. And how do I know that? Well, basically, if you add this angle and this angle together, the thetas would cancel out, leaving 90. And we can see that this whole angle is 90. So basically, as long as you just remember that that can be labeled as theta, I think you're almost there. So what I'll do is I will create a triangle with the x-axis, and we know that's theta. Now, this part of the expression said, what is sine of that value? So sine of that value means the opposite side. So if we're dealing with this angle here, which is 90 minus theta, the opposite side of that, believe it or not, would be this side here. Now, I never said draw a line connecting to the y-axis ever before. In this particular case, it does help us understand that what they're trying to get us to do is they're trying to get us to figure out what this length is. Well, that length is exactly the same as this length here. Okay, we can see straight away that if we drew a line across there, that length and that length are the same. But there's an easier way of doing that, because if we've been told that that is just simply theta, the adjacent side of that would be equal to cos theta times h. So therefore, that this length here is going to be cos theta, the adjacent side. Hence, these two expressions are equal to one another. Now let's go ahead and see that all over again, but with cos. So we're going to repeat it in the same fashion. Let's just do it here. I'll use 90 degrees again. So we start off with 90, and then we subtract a certain angle. So we go to 90, and then we subtract, so we'll be coming back. So let's just say we ended up here. Therefore, then, that angle inside here will be 90 minus theta. And for all the same reasons as I said before, this angle will be theta. Okay, add them together, we get 90. So we go ahead, draw our triangle there, and I will put a dotted line here, okay, because it will be necessary just to prove this. This is saying, what is cos of that angle? So in other words, what is the adjacent side? Well, the adjacent side is this side here. So let's go ahead and use a slightly different color. Here, this is the adjacent side. Right, but what is that equal to? Well, that is equal to this side here. Right, we can see that they are the same length. Therefore, then, instead of just figuring out what all of that is, we can just simply say that that length is equal to the opposite side. So therefore, sine theta. Okay, so I have two exam-style questions here. They're worth 4 marks. We should be able to do them quite quick. Let's have a look. So sine negative theta plus 2 sine theta. Well, we just saw that in property 1. If we moved in the clockwise direction, that would be minus theta. So this value would be theta, but we're moving this way. And if we draw a triangle, we recognize that sine means the opposite side. So in other words, they want us to know what this side is here. So therefore, that height, that vertical height there, would just be negative sine theta. Okay, because it's minus, because it's below the origin, and vertical is to do with height. So therefore, then this expression up here will be negative sine theta plus 2 sine theta, resulting in just simply 1 sine theta. There we go. Just sine theta. Okay, on the one on the right, then we have 90 minus, so this is like one of the later properties. So we're going to start with 90 degrees and then subtract theta. So we're going to start with 90 up here, we're going to subtract theta, so we'll be at this location here on the unit circle. Now, if I just zoom in here and I just write that down, that 90 minus theta is here, then this angle, as shown in the previous property, would just be theta. The sum of those two make 90. So what I'll do is I'll just quickly draw the triangle here, that if they're asking us to figure out what cos of this angle is, that means the adjacent side. So basically, the adjacent side is this side here. If I was just to draw a dotted line through here, remember, we don't normally draw a triangle on that y-axis, but the adjacent side would be this. Okay, so that side is exactly the same length. So if I just draw a line there, is exactly the same length as this on the right-hand side. But on the right-hand side, I can easily find that length because I can just say that that is equal to sine theta. Remember, opposite side is sine theta times 1. So therefore, that numerator is actually sine theta. And let's just use that same approach for cos. So cos is 180 minus theta. So let's go over to this unit circle again here. Let's go round to 180, which is over to here, minus theta. So that means we'll end up somewhere here, right? And if we just draw a triangle, now if you just think about what I said there, we went round to pi, all right, round to 180, then back theta. So when you go back, you would form theta with the axis here. Now, what they're suggesting is that we simplify that. So cos means the adjacent side. So the adjacent side means this side here, and we can see that we're horizontal to left of the origin. So this is just going to be minus cos theta. And we can double check that by using that acronym all students take calculus, ASTC. And in this quadrant, only sine is positive. So that also confirms that my result should be negative. So it was negative cos theta. So let's go back up and just replace the denominator with negative cos theta, and we're almost there. And there's one more identity, and that is sine over cos is tan. So the final result is negative tan theta. Finished.
Show's over, mother.
Let me know how you get on in the comments below. Don't forget to like and subscribe to the channel. See you next time.